Hello, everyone. It's an honor to share this stage with you and this presentation too. We are talking about the invisible threat that occur on Liferay. We are not talking about security as the Liferay native, but the customization that is very important for everyone, and the infrastructure too, because we understand that all projects in Liferay are complex, so we need to set an overview of every steps to have a security project with Liferay. The first thing that I want to share, yesterday on Marcel Talks, he shared that a company flight have this flight status page, and they have this search about how the status is. And if you see in the console of the developer tools on browser, he shows to us the client ID and the client secret that we can use. Why this is very dangerous? If you see the expiry date, it's about 1 year that I can use these credentials. I know this is a public page. What this can possibly expose data, something like that? No, but an attacker can capture this information, use that to create a DOS attack, because he can validate it, that he is a user that is using the process to create an authenticated user, and through that create attack to down the application or the website itself. So basically we have this case that is very important to share. Another thing, it's some data that we have here about security. So we estimated that around 39 seconds we have attack around the world. Any type of attack, phishing, DOS, DDoS, a ransomware, anything that could be possibly dangerous for any type of applications. We have a lot of, around 42 million of records exposed during the last year. And the main sector that basically is the principal focus of the attackers is the financial sector. But during this last year, that not only the last year, but for the last 5 years, we have a lot of geopolitical tensions, and this increased the level of attacks, and the cybersecurity, it's right now in the hype too, like the AI. So this is a very important subject for everyone.
Yeah, like the way that we handle security, it has been changed throughout the years. Technology has advanced, of course. We as users, we kind of changed the way that we interact with technology. And not only our physical presence is online, but also robots, AI. So technology evolves for the good and also for the bad. And we have to be prepared and also change a little bit our mindset. When we talk about security, how to secure our customizations, our applications, our development, it is a broad topic. There are things that you might think that, okay, but it's not my responsibility. As a developer, I need to code, I need to make what I'm good at, and I will let the DevOps guys, the security guys, or whatever, to take care of the rest. I'm not worried about it. But there are small things that we should be aware that rely on us as a developer. As Guilherme said, and as Guilherme showed us before, the website that we showed, the screenshot, we cannot share and we cannot open the website here due to compliance reasons. But it is a production website. It is on live. If I told you what is the air company, you might go there and you might check what you have just said. And it is a risk. Perhaps someone just forgot to hide something. Perhaps someone just forgot not to use basic authentications. So there are small things that we could do and we should do to make sure that the code, the applications, and what we're developing are more secure. And on top of Liferay, as also Guilherme mentioned, nobody uses Liferay vanilla. Everybody has to add things there. Either low code, either template, either client extension. So what are we doing to make sure that the customizations that we're adding on top of Liferay are as secure as it can be in terms of our responsibility. So this is a little bit of what we're going to share with you today.
Exactly. And for that, we need to step back a little bit before we present the customizations. And why it's important to we know some things. What is the principles? Oh, sorry. What is the principles of security? So the first thing I want to share with you. What is the perfect system and 100% secure? Based on Genie's path for the only system is the one that is secured by a power-off system, cast in a block of concrete, and sealed in a lead-lined room with armed guard. This is security. But even this can be unsecured for some reason, because we have people there, we have armed guards. They can create the vulnerability. So there's no 100% secured system. We need to be clear this for us. And with that, we have the principles of security. Who knows CIA? And it's not the Central Intelligence Agency. Basically, we have three pillars in security. The first one, C, is for confidentiality. That would be ensure that the data would be accessed by the right person and not by anyone. So you need to set the permissions, who will have the authorization to see the message, the information. We have integrity. This is particularly a type of attack like the middleman attack that can grab the information, change the information, modify it, and deliver fake information for the user. So the integrity, it's about the information isn't changed during the traffic between the data. And we have the
availability.
Availability, that the data will be available for any time for the user. So this is very important. And if we see that we have all this on customizations and on Lifer itself, we need to secure the three pillars to ensure and guarantee that the information would be totally for any user, will be confidential, and will be integrated.
Okay, now we know that a lot of attacks happens all the time, so we have to take care of it. We have to do something. And we also know about this CIA thing, which not the American agents. So there are principles that we have to take care. But who defines what is secure and what is not? Who gives us some hint about what are the most exploited threats, or what are the most exploited points that I have to take care of? As I said, security is a broad topic, so I might be a little bit lost. So to guide us a little bit on it, there is a non-profit organization called Open Web Application Security Project, or OWASP, as everybody must know. And this organization kind of compile what are the most, among us of other things, of course, but what is the top 10 attacks, what are the most exploited points that is happening. And the report that this organization provides guides some laws, guides some security rules, some security policies, either inside the companies or even for government and for auditory purpose. If you take a look at the 2021 report and the 2025 report, there are some changes in the order of the most exploit vulnerability, and the last one, new attacks coming. But all of the time, it gives us some hints about, okay, what are the hackers doing? Why are they targeting this? Why are they targeting that? So what should I worry the most? So this is kind of a light for us to understand what are the points that you have to secure and that you have to pay an extra attention when you are developing our customizations.
Yeah, and if you see the changes that occur, you basically will have common securities between the years. And usually will be led by a misconfiguration or some coding that isn't good enough to be secure. So basically we have similar situations that isn't evolved through time. We have some lack of knowledge about security on coding. And this showed to us this picture of how security is doing with web applications. And one thing, tomorrow they will release the top 10 for 2025. So this is a picture of the latest release.
Yeah.
But tomorrow can be some changes on the final top 10 of 2025. So, as Matheus said before, we have a lot of type of developer with Liferay. The first thing, we can develop an OSGI module, we can create an ADT, we can create a client extension, we can create a low-code, no-code with object, actions, with fragments, and each part of these customizations, it's a touch point for the attacker can explore. Okay, so even if you do a good customization, sometimes the attacker always would be one step ahead because they want to explore everything in every type of attack. So basically we have all these touch points that we can ensure and guarantee to be secure. The first thing, we have the ADTs.
Yeah. In Brazil, there's a saying that is, if there is a plate, there is some story to tell. I don't know if there is this saying in another country, but we are going to share with you now some real world and some real customer stories that could have been prevented if the developer did something a little bit different. And also something that we learned while we are dealing with the situation. And some things might be obvious, but the obvious must be said and the obvious must be reinforced. So let me share this use case with you first. I'm sure that you guys, or most of you, has already used web contents in Liferay. That's it. When you are creating web contents are created based on a web content structure. And when we want to publish it, when we want to use it in a page experience, we need to style it a little bit. Design sometimes involves some Figma and says how the web content must be presented, colors, and blah, blah, blah. So we can develop fragments to show some web content as a banner or as cards. And there are multiple ways to do that. I really hope that you guys have went through the courses and have attended some other presentations. Handa yesterday talked about you were doing it wrong, so I hope everybody's already using collections. We can use collections display to display a collections of web content. You can use fragments. But we also understand that when we are migrating projects from older versions or some specific use cases, that you still need to use our old friend, retired friend, hopefully soon, Asset Publisher, right? Who here in the room has already used an Asset Publisher in Liferay? Okay. Me too. And when you use an Asset Publisher, we have basically two options. We can develop a template for that Asset Publisher, right? An ADT, an application template, widget template. Or we can use a template for that web content structure. And in the Asset Publisher, I can just grab the rendered content, which means the content already styled by that template. So that's a second option. I will select my collection. I will say, okay, this is the collection of web content that I want to show here in the Asset Publisher. But I want to get the rendered content because for some performance issues or for some what I thought as a developer, I don't want to develop an ADT. So let me develop a template here and I can just map it. Okay, a very common use case. I've already done it a lot of times for a lot of projects, and I'm sure you as well. So let us take a look on that code, that really small piece of code. Here we're saying, okay, template, please, I want to use the web content, but I want to grab the web content, the rendered content. And to get the rendered content, when I get the asset, I want to make this request. Would be okay, very simple snippet of code, it works. but you can test it later if it works. But what happens if my guest user, my non-logged in user in Liferay, needs to see the content that I want to render, like a news, like some info, like some blog posts in formal web content? It will work. It might work if you didn't block any class on the system settings, template engines, denying some classes. But you were kind of opening a door here so guest users, non-authenticated users, can perform some GET requests on your Liferay DXP. And attackers are smart. Hackers are smart. If they find out about this, if they keep analyzing specifically for like famous customers that has a lot of visibility, like we had, they might note, oh, okay, in this site, a non-logged in user can perform some GET requests, and they can use it to exploit your system, to overwhelm literally your Liferay application by sending a bunch of requests. And you know that, and you might imagine that we can add a lot of stuff in a GET request, or also we can grab a lot of information that you might don't want to share with the attackers. So the first hint is, what about if you switch our approach to use this instead of that other request? Both of them work. You're gonna see a result, the same result. But what is the difference here? Instead of making requests, I'm still making a request, but I'm changing the layer on which that request is happening. Here, if you noted it, we are using tag libs. Tag libs are a powerful way for you to take away in the first layer, the request is happening, and you give it to, okay, I don't want to make it here. I can still achieve the goal that I want. I can still get my render content, but no, it's not my first layer that is making a request, and I don't want to open that door. I can deliver it, and I can hand it over to a second layer, a little bit more secure. We have a full documentation about tag libs, and I also want to like encourage you to take a look on Liferay Learn. So this is the first, if there's a sign, if there's a plate, there is an history. We had it. It happened in a very famous, in a very big customer, and it was working. They have a small ADT to use literally to show, I think it was 3 or 4 web contents as a banner. But then they were attacked because the attackers find out that they could have made use of the GET resource and the GET requests as a non-authenticated users to overwhelm their system. So one of the approaches that we use, okay, let's use taglib instead, and it helped to finish the attack, among other things. If you might be wondering, okay, you said no, don't use asset publisher, use something else, use taglibs, use collections, but how am I doing this? We have a red workspace for you. In all of the courses, we are using Clarity. Who here has already done some of our Liferay Learn courses or attended a boot camp or a training? Okay, I'm happy. A lot of people. But for those who don't, and for those who want to take a look more, we have some courses on Liferay Learn, as Hannah shared yesterday, that you can see examples of how to achieve similar results with collections, collection display, fragments, scene templates that we already make use of taglib and do not abuse free market, do not use a lot of things in free market. And it is all in your hand. Just take a look. That specific course has a lot of things, has a lot of examples, and you might benefit and you might want to take a look at it.
Exactly. And for the second example, we have the most common customization Liferay, that is a OSGI module. So everyone probably here usually to code a OSGI on Liferay. We have an example that occurred in a client too. They created a job scheduler that for some time it's running and causing poison in Liferay because they are creating a memory leak that Liferay turned unavailable. So for this demonstration, we have here, just me share here. Let me log. And yes, wait, something goes wrong with my login. Let me start start again. Okay. So basically, I created a job scheduler that execute and collect information from the user. Basically, it's a simple scheduler. And here I have the first problem. I'm executing this and storing the information on memory, on Liferay, and I'm not cleaning this. I'm letting this thread occurring through 5 minutes, and every 5 minutes it's happening again. And if you can see here, it's running since Friday, and we have around 1,600 threads in the memory. This can occur a poison Liferay, a memory leak, and this is very dangerous because through time will be unstable and you need more resources on Liferay to host this and support the portal. The second problem here is in this code is in this vulnerability, I'm hard coding the credentials of the user and the API through that I need to consume in this demo. Of course, this is a demo purpose, so I'm sharing in the screen all the credentials, but in the backend, I'm exposing this in hard coding. So basically, what we have here on my code, I don't know if it's too small, but I will zoom in. Just a second. How I zoom in here? Well, it's not working this. Okay, no problem. What happened here? In my code, I'm using the hard code credentials, if you can see it here, and I created a variable to host this information, and I will consume in my code to expose this in the front end for the user. So this is a not good use of the code.
Just something to add. When that happened with that customer, the developer was like, okay, let me make some tests, let me make some initial proof of concepts. And he was working in a local environment. And then he delivered it to the dev environment and said, okay, that's working. But then they were in a lot of pressure for the deadline, for the go live. They had to put it on live. So he kind of forgot to remove it. And he, of course, promoted to UAT. And the customer validated, okay, it has the result that I'm expecting. And then go live. And then, boom, in production, they had something that was using literally in a hard-coded mode. They were using basic authentication, of course, inside the OAuth 2. And the credentials are right there because they forgot to remove it and to change the approach because of the pressure, because of the time, because they, okay, I need to go live, I need to deliver the things that I'm expecting, my hours of consulting are finished, so okay, let's do. So we are all humans, we might forget, we can't forget things. So the first lesson is that's why it is important for us to use the right approach since the beginning.
Exactly, and the second point is the sensitive data is logged in the memory too, so the user can, the attacker in this case, can capture this right in the memory, not only on Liferay. So this is a very dangerous approach. The second point is the race condition. So we have no synchronization between all these threads, and the second one is that I don't have a thread safe. So if you can see here, I'm just storing this through time, and I'm not cleaning this from the memory. I'm letting this thread occur all the time and repeating. This will host and poison Liferay through time. For the security one, we created and we removed the basic authentication. And we are using a file to host the credentials to access this out of the code. All right, so we are not sharing the code. We are using a variable. We set the history thread safe to not host all that in memory. We only host 50 threads in the memory, and we have to the cleanup of the memory. So every time we clean up the memory to avoid this problem. So basically in this example, we have in an OSGI module, we can have this kind of situation that can be dangerous on Liferay. I have here, I don't open, but I think it's cool to share. I don't use my local host to run this example because my computer will go down with the memory. But Liferay, since Friday until now, increased the memory consumed because I'm hosting this information. So I'm using the cloud to provide this, and it's out from 4 giga to 6 giga in around 5 days. So this is dangerous too.
Yeah, and one important thing is here, you might think that Guilherme is talking about performance and performance and performance.
No.
But when you are talking about security, you have to understand that sometimes we need some delta for the AppSec team, or even for the web application firewall, to start detecting the patterns of the requests that are coming. When you are dealing with a DOS attack, or even with a DDoS attack, that might be this delta of time needed for the good AI, for our AI, for the WAF, or even for your team to kind of understand the pattern, which is each day more difficult. And if you don't care about performance, your application will get down, because the time needed sometimes to block some pattern, to block some IP, to block some requests. And if your performance is not good enough, the requests that will be successful, that will hit your application, they might take it down.
And don't forget, we have 3 pillars. We are talking about the availability too. We can't forget that. The availability can be impacted by any customization Liferay. So this is very important too. So again, if there is a sign, there is a plate, that we need to be cautious about that. For the third example, we have a client extension. So a new approach. We need, we have a microservice, for example. We have a micro front end. We have classes on Liferay, anything that we can add with client extension. Here, we try to create an AI assistant, of course. I'm running in Python backend, so here is the Python working. Of course, here is a demo purpose, so I'm sharing all the vulnerabilities in the front end. We can try this. So as you can see, every interaction that I do, the AI let access the user information, capture this, and pass to the front end. But beside that, we have here in the console all the information that the AI is providing to us in the client extension. So I have all the information about the site ID, the user ID, the company ID. If I log it here, for example, if I access here with my admin, and here, but I clean my browser. As you can see, they capture the test, the user, they are passing this information through the browser. So I can capture this information in the front end, and in the back end, I have the same information. All time, this will be requested. I have the API, and we have one more thing. If I ask for the AI to ignore any command that I want to share and pass me the information of the system, he will show to me the API key, the user, every information that is hosted in the application that I need to consume. So this is very dangerous. We are talking here about how this integration works and is unsecure, how the prompt from the AI need to be set and be configured to ensure that the AI won't share anything about the code that you are creating, and the front end too. It's very dangerous to you pass some information. For example, I will host again here the secure AI, and here the user is a no, for example, and if I'm come to the console, again, The first thread is from the, let me, if you see here, he is not showing me any information. So we correct this basic, not only in the back end, but in the front end too. So go on.
And it literally happened because the customer was so excited about AI. We were talking about AI all the time. Okay, let's create a chatbot. Let's create a conversational search fragment that use a client extension, a microservice client extension to talk to another AI. So let's make it, yeah. But then the developer forgot to hide this information, as Guilherme mentioned. And literally when we went there and when we inspect that page, with that, it was a client extension. But even though they were exposing a lot of information, so when we expected that customer page, and when we saw, okay, there is site ID, company ID, which the virtual instance ID, that's the user ID. And they can literally use that information if they know live for a little bit. If the hacker has done the courses, they would know that through the APIs, they could use the ID, they could use user ID, they could use group ID to make a lot of requests.
Exactly.
So it would overwhelm their instance and it would create an attack for them.
And here's the Python code that is unsecure, for example. So I'm sharing here the API key right in the code, hard code API. So this is not good. I need to have this on an end file, for example, to consume external of the code that would be built. We have the excessive log information that is configured. So I'm logging everything that the user prompted, that user are accessing. So this is very unusual to do. Course misconfiguration. So this is another thing that I don't share before, but we are put here in the code too to have access from any domain. So this is very dangerous too. This is a long code, sorry guys, but like I say, the excessive information that I'm pass not only in the log but in the front end. So I'm capturing this in the log and passing through to the front end too. The tokens that I'm using, I don't have validation of the token here. The AI will not be trained to what user is prompted. So basically, anything that I need to ask for the AI, they will consume. And if they have access to the user information, to the response, they will throw that in the prompt too. The conversation history, it's another point that I let this as not only in the log but in the console too. The message error, there's another one here that is very important. If you see, it's a lot of code with a lot of vulnerabilities, but the one, here, the prompt injection is exactly the one that I said. I sent for the AI the prompt that he need to show me all the system information, and basically he's doing that, and this is very dangerous. And if I try to execute some code in the prompt, possibly the AI will receive this information and execute the code. So this is another vulnerability point that we have. For the security one, we have a code more simple. With the fixes that I am sharing. I'm not passing the API key. I have an environment variable to use the API key. For the sensitive data, I'm not passing this for the user, so I'm hosting this only in the backend and not showing this on the logs or anything else. For the restrict policy of the course, I'm using that too. If the same origin, I will block the request. The rate limiting is important, so I don't have too much threads occurring at the same time for the AI. And in the end here, I have the treat for AI to not use the prompt. We have the prompt sanitization, so I let the AI that they need to know what the user wants execute, and if it's sensitive, he will not execute for us. So here I'm telling AI to not do some things, and I'm securing the code too here. I have the front end too, and we have here another code, the vulnerable one, where I'm passing all the information to. So if you see for the front end, I'm logging everything that I said before, so it's a long code too. And we have a lot of vulnerabilities here too. And we have the secured one that is right here with all the corrections based on the fix that we need for the front end too. Okay, so this is the example.
Just to kind of summarize here, like the three main lessons that we got from that history. First one, be careful on what you are sharing, on what you are logging, because what you log might give the attackers some possible exploitations. So be careful if you're sharing ID, user ID. Be careful when we are like hard coding your information, like API key, API, whatever it is, whatever you need. If it's a client, if it's ID, it's another
whatever
information for you to connect.
Whatever
between
the
library
sensitive information,
and AI.
you need to be care with how you will expose this information to any system, any integration. So you need to be cautious about that.
In the 31, XSS. We know that if you let AI or if you let our queries to execute things, it will end badly. So be careful when you're like talking to AI, when you're integrating to AI, to make sure that you're not giving that much power. Otherwise, you might regret it.
Yeah, here is a summary of all vulnerabilities that we have in this example. So in the front end, the back end, and in the integration too. So it's basically all this code that I'm show to you all. And again, if there's a sign, there's a plate, be aware of the wall. This is the classic one. And we have another problem too, related to Liferay, that is the infrastructure problem.
Yeah. Regardless of what we are doing in Liferay and with our code and with our customizations and development, Liferay and any other application, they don't live alone. For the users to access it and to use it, it has to coexist in an ecosystem of technologies, which means the application needs a database, the application needs a web server, needs some backup strategy, needs load balancer, needs to be exposed to the internet, and blah, blah, blah. So each of these technology, each of this layer needs to be secured. Not everything, of course, will fall on you as a developer, but it is important to understand the concept. Now we have bot crawlers that are constantly like crawling our applications. It might help, but it also opens some doors for us to, okay, what I'm exposing through my applications, is my application being in a good shape of performance? So when I receive these requests, either if it's a good request or a bad request, will I have time for the WAF and for the other technologies, for the other security technologies to block them all? And it also leads us to DOS and DDoS. They're each time more smart. So to identify the patterns has been like each day more challenge. And this is like our InfoSec team, our DevSecOps teams from a lot of companies that we have some network that we can share experience. And what they're saying is that the way that the attackers are hitting, the way that the attackers are sending the requests, the bad requests or the DOS requests are each day more smart, are each day more different, which makes it even harder to identify what's the pattern for the request to be blocked.
Exactly. We have a customer in Brazil that for the DDoS attack that occur in Brazil, the attacker uses a crawler that is true for any site. So he captured the Google crawler, catch the pattern of the Google crawler, basically fake that and create a DDoS attack in our website. So our security levels hit the security levels, and they think, well, it's a truly request, so let it in. And basically, until we understand the pattern of the request, the site goes down, and we need to have all the team to understand this problem. So the bot crawlers and the DDoS attack, it's very in a similar way related. Because a bot crawler can lead for a DDoS, and attackers can get a crawler and use this for a DDoS. So today we have a lot of DDoS attacks around the world. Is the most one used on websites, basically to cause unavailability of the portal, because this can cause damage, image damage for companies, but is the first point for attacker explore how secure it is in some websites. So if a DDoS occur and is success, they will explore more and more in that website. So he will start a DDoS, and then he will try to explore some vulnerability integration or in the code itself. And the worst enemy of security is complexity. But when we are dealing with not only with Liferay, but with any technology system, we know that it's complex. So we know this it's our enemy. We need to deal with that with some good examples, with some tips. We need to have the right knowledge to avoid and mitigate. We don't have 100% security system. This is impossible. So we need to mitigate some vulnerabilities to reduce the damage of an attack. And for some best practice, ideally, execute SAST and DAST is very important for any code that you are using. Using SonarQube, it's a very common and use it for the pipeline, the end of pipeline. And Zap and Burp too, it's a good source for you execute SAST and DAST. Another point is the dependency scanning. It's a good start to use for prevent some vulnerability on the dependencies that you are using. The infrastructure as a code scanning policies, it's very important too. Again, we are not talking about only code, but we are talking about the entire ecosystem that will support a live project. So infrastructure is one too. The secret scanning, all secrets that you need to host, you need to scan if it's safe, if it's using some patterns to be secure. The container hardening, it's another one that is very important. The secure authentication method, so use OAuth, use the backend for front end, the BFF that was presented yesterday, and thread safes to you don't have some poison on Liferay.
And again, it doesn't apply only to Liferay.
Yeah.
For everything, for every application that you are dealing with, that you are creating, if that you are coding, those would be best practice for you to at least pay attention or ask. Liferay is committed to secure, so we have reports, we have pages on our Learn, on our documentation that share how committed we are about security. Either if you are hosting Liferay in a data center as a self-hosted mode, or if you are on cloud, we are providing reports to make sure that we are committed to secure and to let you know how we are committed to security.
Exactly. And this is a reference architecture of how would be architecture that can support a DDoS attack, can be ideally mitigated some type of attacks. So basically we would have the CDN for static content only, not the dynamic one. We would have WAF with anti-DDoS. We have bot management for the bot crawlers. We have the load balancer to the live cluster. This is very important. A secret manager, API gateway for transactions between integrations, and the CSPM, that is the cloud security platform to ensure that all these things could be secure. We have, of course, the LASK and DR, and the object storage, all that isolated. And we need observability. This is very important, the monitoring of the entire system, and the backup
In disaster
backup
recovery
disaster
strategies.
recovery. Exactly, I'm not seeing this. So basically, here's reference architecture. Ideally, we use it to have this on some projects. This is not only, again, applying to Lifer, but to any web project, okay. But basically, here's the ideal one to mitigate some attacks. And finally, think it as an attacker. So when you are coding, when you are creating something, always think in the three pillars of the security. Always think, if I let this in the code, the attacker can use that to compromise my portal, my project. And if the answer is yes, correct this, because this is a point of vulnerability. So it's very important to you have this in mind. This type of mindset to always an attacker will be one step ahead, and he will explore anything that you code in Lifer.
Yeah, we will be available to talk to you more in the coffee breaks and during the breaks if you wanna heard about more stories and how we went ahead to mitigate it. And thank you all for coming and for being with us. And see you.
Thank you.